In earlier videos, I've already stressed the importance of the important role of architecture in the link between business strategy and technology strategy. And I don't want to deep dive on that too much, but the fact is that as our business strategy evolves continuously, also our architecture needs to evolve continuously. And this is where especially leaders with a background in mechanics and electronics often fail to understand how continuous the nature of digital technologies is. I mean, for atoms-based products, you typically have a product development project, which is followed by start of production, and then basically you stop changing as much as you humanly can. You may have some smaller projects to address reliability issues or have a cost down initiative to re-engineer expensive parts, but the default state is don't touch. Software cannot be in that ballpark. In practice, software is continuously changing. We often use, for instance, external components, anything from operating systems to database to open source to highly specialized commercial components that we buy maybe from others. And all of these software components that come from the outside are subject to continuous evolution. And we need to incorporate these just to stay compatible with other systems, but also for safety and cybersecurity, and maybe even from a branding perspective, because we don't want to be the slow pokes that are always running, or where our products always run on the old stuff, right? In addition to that, of course, we will have, once our products are in the field, feedback from the field. I mean, this may come through our sales, this may come through customer support, but also, I hope at least, through a lot of automated data collection. And all of this results in a constant stream of requests for changes, updates, and extensions. Yeah, so very often companies start with providing software updates to deal with defects or other quality issues, but then they realize it's very easy to piggyback additional new functionality on top of that release process. And before we know it, we are actually doing DevOps to our customers. All these changes require changes to the architecture of the product as well, specifically the software architecture. And this is what we often refer to as refactoring. And this is what the technical architecture technical debt community aims to address. And although very often people talk about technical debt as those idiots that have built the software, the architects and software engineers, they just took a shortcut and didn't want to spend enough time thinking about the architecture. But very often, the primary source of technical debt is simply domain creep. Yeah, the architecture was initially designed for a particular problem, and now what we are trying to do with that architecture is evolving and changing, and because of that, we need to change the architecture as well. And this is where I believe it's so important that we think about continuous evolution. Yeah, so and I think that many people that do not have a strong software background do not realize this. The first, I think, takeaway is that you will do architecture refactoring whether you like it or not. I mean, companies that do not continuously invest in architecture refactoring tend to experience continuously increasing debt levels in their systems. And because of that, they tend to become less productive. The quality assurance costs go through the roof. You may very easily have very high profile defects or failures in the field. And often when a company like that ends up in a situation where productivity and quality become really big issues, yeah, the leadership decides something needs to be done. And that's either a major overhaul of the existing architecture, or it is a fresh start by building a new platform. And of course, many companies have traditionally worked in platform generations, which I think is really the wrong way to go about things today. But in my view, the best way to do this is to allocate somewhere between 10 and 25% of your R&D resources to continuous architecture refactoring, and never get into a place where you're in a really bad place. The second belief, which I want to question because I disagree with it, is that people believe that software ages over time. And I think that even though our bodies age, and that's not a choice for us, in the case of software, having software age is actually a choice and not an inevitability. If you invest sufficiently in architecture refactoring, software can stay up to par and can be advanced and proper for decades. And there is actually no reason whatsoever why you would not be able to keep software up to date. Yeah, but it does require continuous investment in architecture refactoring and risk taking when you need to make significant architecture design decisions. For instance, replacing the database of the system. That is a hard choice. Finally, third, everyone loves a greenfield approach where we start from scratch, but few realize what a high-risk endeavor this actually is in practice. A new architecture with new technologies bring its own set of risks that we're not even aware of because often we have too little experience with these new architectures. And also what many people vastly underestimate is the amount of domain knowledge and functionality that has been embedded in our legacy systems. People often underestimate it with a factor of 2 to sometimes even 10. People don't even realize that they have 10 times as much functionality in their legacy systems as what they thought they had. What I've seen happen in several companies is that we end up in a kind of awkward race where the new architecture is under development, but you still need to maintain the legacy system because that's what is generating all the revenue right now. Because you're investing in the legacy system continuously receives new functionality, which means that the new architecture is never reaching feature parity because the new legacy architecture continuously gets new functionality, and the new architecture can simply not keep up with the new functionality that is being inserted. And there are several companies that have a situation where the new system and the legacy system coexist for years and sometimes decades, and that is an extremely expensive and dangerous place to be. So my general advice for virtually any company that I work with is do not start a new platform. Stop thinking in terms of platform generations. Instead, focus on your one and only current platform. Invest in refactoring so that you never have to start from scratch again. So to conclude, software-intensive systems require continuous refactoring for all kinds of reasons. And if you do not cater for this, you will cause huge productivity and quality concerns, and you will have to do a major architectural overhaul anyway. So be smart, invest continuously in architecture refactoring, at least 10%, maybe even up to 25% if you've built up a certain amount of technical debt. And as Philip Johnson said, I mean, the future of architecture is culture. Make sure you choose the right ones.